Welcome back from morning tea, everybody. Okay, I get to do some introducing. This is fantastic. This is Digital K, also known as Kiki. She's one of my friends, so I get to say that. She's a teacher specialising in digital media coding and making, and has been teaching Scratch, Python, and other things to students at all levels in schools and during holiday programs for over 10 years. She's spoken at ICT educator conferences in the past and at PyCon AU in 2016, and we should all congratulate her on being here today. There we go, and she's talking about Pythoning all the subjects.
Okay, hi, so my name's Kiki. Can I just get a quick hands up? Who here is a primary school teacher? Couple? Oh, fantastic. Okay, who here is a high school teacher? Okay, quite a few more. All right, I'm going to be talking about both primary and secondary school. Okay, computer code is now part of almost every aspect of our lives. So why shouldn't it be part of everything we teach? I don't need to tell you that Python is an extremely versatile language and is great for teaching. In fact, I can't possibly show you in half an hour all the uses that you could have for Python in school, but I'm hoping I can give you a few ideas. Okay, and if you want any more details later, or just find me at the conference, or if you want to see my code examples, this is me online and that's my Twitter handle. Okay, everything I'm going to show you, apart from a few external devices which you might want, everything else I'm going to show you is totally free, okay? I recommend that you have Python installed on your classroom computers, which you can get from the Python website. But if you can't get access to install Python, or you're using Chromebooks or iPads, you can use Python in a browser. So you can create accounts on trinket.io, and it's great for saving your work and going back to past projects. Okay, an obvious way to start coding in Python is to add up some numbers, create a variable, learn to print. How about use some random numbers and make a simple maths game? So this is a pretty easy thing for upper primary school students to get their heads around. They could add scoring and a timer and play against their friends. A variation is to make a game where you store a random number and players have to guess the number and they're told if it's higher or lower. So we're just using here if-else statements, printing, and input some very simple maths. So most of the examples that I'm going to start off with are fairly simple things that you could do with kids when they're first learning to code. How about some more practical maths? I got Year 7s to code a currency converter when they were doing a unit on travel. Luckily, I looked up some currency rates the night before because it was the day that the school's internet went down. But the currency converter still worked. So that's an example of something which you could code pretty easily. As I said, I got Year 7s to do it. Middle school students looking for casual jobs could maybe make a simple calculator for their pay and tax rates. And I'm just going to switch now to giving you some actual coding examples. Let's have a look. Oh, where is it? Let's have a look at an online shopping game that I taught some upper primary school students to code. So again, I'm using Trinket, .io to store the code. So we're doing this in Python 2. And as you can see, I've stored a list of things in a dictionary. And let's do some shopping. So we add an item to our shopping list. What would you like to buy?
Broccoli.
Broccoli. Oops, I need to spell that. How many broccolis would you like? 5. Excellent. Nice and healthy. Okay, let's buy something else. What else would you like to buy? Oh, yeah. Okay. How many? 9,000? It might break the budget just a little bit. 9. Okay, that sounds good. And one more. Mangoes. Okay. 3 mangoes. Fantastic. All right, so we got some options here that we could remove an item or view the cart, but I'm just going to finish shopping. And as you can see there, it's come up with the calculation and told us the total amount. This is something that you could adapt to. Of course, you could have anything in your shop. Kids have had all kinds of things like Pokemons and crazy things for other games. But you could also adapt this to have something like a menu and get some kids to work out how, if there's, certain lot of pizzas being ordered, how much dough are they going to have to have? So some very simple things that you could tie into what kids are doing in other classes. Okay, let's just go back. I'm going to be going back and forth between slides and my presentation a fair bit. Okay, so let's move on to the favourite thing that I like to do with maths and coding, which is to make computer art. So computer art, here we're using the Python turtle. Who has used the Python turtle before? Yeah, okay, fantastic. Okay, so you can teach Cartesian coordinates, scale and ratios, how many degrees you have to turn to fit 5 petals around your flower. So all the examples that I've got here, apart from the sine wave, were coded by primary school kids. And by the way, the flower was coded by a boy. So we had a coding art competition last year. Kids in years 3 and 4 used Scratch, and kids in years 5 and 6 coded in Python. And then we printed out everyone's best work, and the winners got theirs ironed onto a t-shirt or a library bag. Let's just see, I've got an example here. Okay, you can go further with maths and Python using Minecraft Pi, which is free if you've got a Minecraft account or if you have a Raspberry Pi. You can code all kinds of three-dimensional shapes, make interactive games, for example, treasure hunts, where Python stores your location as coordinates and calculates how close you are to an object. Or maybe charges you rent for being in a particular area. But if you want to know more about this, check out the video of my PyCon 2016 talk on Python with Minecraft. But we haven't yet done with maths because data. Almost every other subject that we teach creates or uses data. And data is more interesting, in my opinion, if we can look at it. So if there is one thing that I recommend you installing on top of Python, it's the matplotlib package, which includes pyplot. Who here has used Matplotlib? Okay, quite a few people. And who's done plotting on graphs with PyPlot? Only a few. Okay. So once again, I'm just going to get out of my presentation and show a couple of examples. Okay, so here's a really simple demo of what Matplotlib can do. As you can see here, I've got a list, that's my x coordinates, and some y coordinates as well. And all we're going to do now is, if this works, okay, it's come up on my other screen. Okay, so as you can see down the bottom here, we've got the x coordinates and there's the y. All right, so it's a really simple line graph. Let's just add in a couple of lines of code here so that we can see another line being coded. Okay, so I've added another set of coordinates. And once again, it's come up on my other screen. Let's just move that across. Okay, so that's pretty easy. And I reckon a lot of kids could get into doing that. Let's have a look at one other example. I've got here, if I go back to code. All right, here we go. We've got something which is going to be an interactive survey. So if I run that, okay, can we see that coming up in the shell? All right, this is the little survey that we were doing earlier, collecting some data. So from the responses that we've got, how many people were drinking coffee? 9. How many were drinking tea? 4. Herbal tea? 2. Juice or soft drink was 1. Water? 7. And somebody was not drinking anything at all. Okay, and straight away, I've got a little pie graph to show you here to see how many coffee addicts there are at PyCon. And I'm going to be able to straight away click that little save button there and save that as a JPEG, and of course I'll be tweeting that out later. Okay, so there's some examples of using Matplotlib. Let's have go back to looking at a couple more. Embedding this into teaching. Okay, so here I've got one graph that was made from some public data from the ABS census with Year 9s, and another one that was made with some data that was collected at the school canteen done by some Year 7s. All right, let's move on from maths and talk about English. So creative writing is awesome, but I think interactive stories are also pretty awesome, such as the Choose Your Own Adventure, where the player's choices change the outcome. So again, I did this with primary students, and the younger ones made games in Scratch, and the older ones, the sort of Years 5 and 6 kids, did it in Python. So we're using if-else statements, functions, lists for items that the player collects. And there's a pretty good template for doing this at Trinket.io. I might show you that later. Don't forget the classic old game of Hangman, which is not too hard to code and could include a list of words that students are studying, perhaps from a text that they are doing in English. And you can, of course, do your Hangman like that, but you can also draw it using the Python turtle. A chatbot is a simple thing that beginner coders often learn to make. So why not make a chatbot which will talk to you in another language that you're studying at school? Or once again, use a list of certain words, certain vocabulary that students are working on at the moment. And Python is not only for writing, but for reading text and analysing what words are in it. So, for instance, how many times is a character mentioned in a novel? Which emotive words appear more often? Maybe even what was in Hillary's emails. Python can work it out for you. Okay, so here's an example that I did of some text analysis with Python. So I got the speeches that 2 presidential candidates made when they announced that they were running for president in the US, easily available online. I saved the text into a simple text file, and then Python read the file. And I wanted to look at the ratio of words that they used I, me, or my compared to we, us, or our. And so I got Python to do some calculating for me. And here's what I got. First of all, I had a look at this guy when he announced he was running for presidency. And Python did some analysis for me and told me the word usage. Now, I ignored all of the other words and used matplotlib to make a little graph for me of just the ratio between the I, me and my compared to the we, us and our. As you can see, there's about 1/3 of the words you would expect when someone's running for president that they're going to say a bit about themselves. But 2/3 of the words that he used were more inclusive, were about we and us. Then I had a look at this guy when he was running for president and did exactly the same thing with his speech. You notice his speech is a lot larger. And when I ran a graphical analysis, I'm not sure what you want to make of that, but it was an interesting exercise, and you could see how you could do that in the context of learning about politics or some kind of social studies. There won't be another time, okay, easily. So you just find their speeches online. It's so easy to find this stuff. Any speech or text that's available online, you could grab and put into a text file. Okay, here's another way we can analyse data with Python. So Open Weather Maps has an API that gives you current observations for anywhere in the world and 5-day forecasts for free. Let's have a quick look at how that works. Where is I? Okay, I'm just going to move this back over into the other screen. Okay, so importing a module PyConAU for Open Weather Maps. And if I run this now, we should get the current weather observations for Sydney. Notice that we've got pretty high humidity. It's not surprising. And then if I, for instance, wanted to change where we're looking at, maybe I'll look at Melbourne. Anyone here from Melbourne? All right. Oh, it's a bit colder in Melbourne at the moment. And let's try one more. Let's try, I don't know, Tokyo. Country code. Oh, nice and warm. Okay, so you can see once again how you could do a comparison, and you could plot those statistics maybe even on some kind of a graph or some kind of a bar chart. All right, so geography. Okay, if we want to do our own measurements, we're going to need external devices. And there's plenty out there, but if you've got a limited budget, there's really only a couple that I would recommend. One of them is this thing which I might just pass around if I ask Nikki to pass around, the BBC microbit. Who's used a microbit? Yeah, awesome. Okay, it has some really useful built-in sensors. Plus you can attach your own just with alligator clips. So it's really useful for collecting data. And the microbit website has got its own programming environment. It's got a block-based coding tool and also JavaScript. But as well as that, you can use MicroPython. And there's a talk right now in another room about MicroPython. The best editor to use is called Moo. And it's free to install, and it allows you to download your Python code straight onto the microbit. So once again, I'm going to leap across to my other screen. And here we go. Here's the Moo editor. I've got a microbit attached to my computer, so I'll give you a little quick demo of what happens if I flash the code to my microbit, and we should see it coming up. Is that working? Here we go, yes. PyCon rocks. Yep, and then just some random numbers. Okay, so that's one little bit of code. Let's have a look at another bit. This time, I've got some code where I'm going to collect, using the inbuilt temperature sensor on the microbit, the current temperature in this room. If I hold down my arrow key, we should see it's saying it's 28. Okay, it's nice and warm. And if perhaps I, oh, okay, gosh. Blow on that, we can see that it's going to change over time. Okay, I've got to quickly move on because I've got more to show you. All right, so, okay, the microbit can be used for all kinds of physical activity. And of course, you can use it to collect data on yourself, and you can use it to transmit data from one microbit to another. More things that you can do with it. Science, more science. And of course, there's other external devices as well. I'm not going to go too much into it, but if you really want to get into physical computing, I strongly recommend checking out the Raspberry Pi website. Oh, and one more thing on science. Shout out to the Australian Computing Academy. You've got a very cute little Python and biology module on their website. But I have to, before I finish, leave some time for talking about my other favourite subject, which is music. And there are two things that I want to show you. One is called PySynth. And Python synth is a very small and very basic way of converting notes into a WAV file. So if I run this now, it's very cool. It shows you all the frequencies for all the numbers while it's doing its compiling. So it's writing a song to, yep, and I can just play this song now for you. There's my little Monty Python reference. And one more thing that I just want to show you is something called Ear Sketch, which is a lot more sophisticated than PySynth and a lot cooler. Let's have a very quick look at Ear Sketch. Ear Sketch was developed to teach young people how to code with music. So there's all the code, and here's what it can sound like. So once again, we're just using some really basic setting up variables. There's a few functions in there that are unique to Ear Sketch, but you can use all your standard Python functions as well as for loops and a whole pile of other things. But I might have to leave that one for another PyCon talk, because I've now pretty much run out of time, and I want to hear if you've got any questions.
All right.
Thank you.
Thank you so much, Kiki. I just want to go and play with Ear Sketch now. That looks like a yes, I have a question. No, I just want to go and play with Ear Sketch.
I have a question about Ear Sketch. What level of programming do the kids need before you would let them onto it to kind of try to create?
Pretty much zero. There are actually some really good tutorials on inside Ear Sketch with videos. And it teaches you all about what you need to know. Like the first thing that they teach you is how to make a variable and to store your loop. And I'll show you one more thing, which is on the Trinket AU website. Just find that. They have a course called Python MC, and that's using Ear Sketch. So it goes through all of the things, and it's got embedded in it some videos about how to do how to make variables, what are data types. It's really a fantastic resource there, and yeah, they've got some pretty cool hip hop producers to help make some of the loops and stuff for it too. It's a really useful resource.
All right.
There's another question.
Is it super short? Super short.
If you were to start somewhere, if you only have iPads at school, is there anywhere that you can begin with Python?
Yeah, so as I said, this site, trinket.io, it's all browser-based. So if you've only got Chromebooks or iPads, go to this. You can start coding with Python straight away. You'll need to create an account if you want to save your work, but you don't even need to do that just to start coding straight away. And also, by the way, Ear Sketch is also browser-based. So there are some things that you can use for coding in Python if you're not able to install it. It is only Python 2 unless you pay. There is a Python 3 available, but it's a paid option. But look, I've been able to do a lot with just using Python 2 with the kids. It hasn't been a problem. Any other questions?
No. Thank you. you
Okay.
very much. We've now got 10 minutes, 8 minutes. Yes, thank you. Yes. Before I let you leave from the stage, I need to give you a coveted PyCon mug.
Wow.
Thank you very, very much for
Awesome.
sharing. We've got about 8 minutes to change rooms or stay here for more awesome stuff.